Hi everyone, I'm Kunal Sanke. Welcome to my channel Code for Wireless. In previous video, we discussed basic understanding of LLM, and in this video, we will begin to understand transformer architecture from the famous paper Attention is all you need. So let's get started. Now this is the transformer architecture. The first part is encoder. So this is an encoder part. It has input embedding, positional encoding. So any word embeddings first get transformed using input embedding. It gets then added with the positional encoding, and that encoding vectors is get then passed through this multi-head self-attention network, and then we have feed-forward network. And the second part is decoder. So the decoder has output embedding, positional encoding similar to encoder, and it also has multi-head attention, a slight variation of multi-head attention and feed-forward network. Now we will try to understand each of these blocks in upcoming videos. That's how we will get the full picture of this transformer architecture. So let's begin with input embedding. First, let's consider a sentence. The cat sat on the mat. The first thing that we do here is tokenize the sentence. Now, what does tokenization mean? It means that we divide the sentence into its individual tokens. And here, the token could mean individual words or subwords. Now, for this specific example, let's consider we tokenize sentence in two words. So each of these words are token. Now, next thing is assign some IDs to these tokens. Now, how do we do that? First, we need to have a vocabulary. Vocabulary is nothing but a dictionary of certain size. So let's consider for this example, we have a vocabulary of size 50,000 words. Now, each of these words are present in the vocabulary. So, for example, the word the is a key and assign a number 2045. Similarly, another word, for example, let's say on, is assigned a number 32, and so on. So, all these words are present in this vocabulary and are assigned a certain value. Okay, so SAT is assigned value 789, on is assigned 32, MAT is assigned 687, even the period is assigned a value 133. Now each tokens are transformed into embedding vectors. For example, this token which has an ID of 2045 is assigned a vector of certain dimension. Similarly, this token SAT which has an ID of 789 is assigned into this vector. Now, how do we do that? So this is a learning parameter. We learn these embeddings during training. Now also see this word the, which has the similar tokens, also has a similar vectors. Now LLM try to learn these vectors in a way that word which are closer, for example word cat or dog, which are similar in terms of being animal, they will have a vectors which are closer to each other in high dimensional space. Now, in this example, we have a vector of size 512. Now, this is the size is specified in the paper, and again, it's a hyperparameter. Now, look at the token the here. They have the same token IDs 2045, and they also have the same embedding vector. In the next video, we'll talk about positional encoding. Why do we need positional encoding and how it gets added to input embedding vector here? We'll learn about that in the next video. Thank you for watching. Subscribe my channel Code for Wireless. See you in my next video. Thank you.